So where were we? The monomolecular absorption theory. Surfactants are capable of reducing the interfacial tension. This facilitates the immediate formation of small droplets. Furthermore, its importance can be understood by considering the surface free energy changes during emulsification. So there is an equation delta G equals to gamma O by W into delta A, where delta G is increase in surface free energy, gamma O by W is interfacial tension of oil in water interface, and delta A is increase in surface area of the interface due to droplet formation. Okay, so del in equation in that equation delta A is increased due to formation of small globules. Usually these small globules tends to combine with each other and form separate phases, but formation of smaller droplets is important in the preparation of an emulsion. So, delta A cannot be altered to get delta G is 0. The only option is to reduce the interfacial tension, that means the gamma O by W. So please the note the equation delta G equals to gamma O by W into delta A, where delta G is increase in surface free energy, gamma O by W interfacial tension of oil water oil water interfaces, and delta A increase in surface area of the interface due to droplet formation. Previously, in case of suspension, we have also read this equation. I don't know if you remember or not, but this equation we also already covered. The only option is to reduce the interfacial tension gamma O by W. The surfactants achieve the objects and produce stable emulsions. This factor is of secondary importance in stabilization. Next, ionic surfactants impart charges on interfacial films. These films exert repulsive forces between two approaching globules and prevent their coalescence. This mechanism is of minor importance. Non-ionic surfactants also produce good emulsions. In such cases, ions present in the aqueous phase often get adsorbed onto the monomolecular film, thereby preventing the coalescence of the droplets. Next, oriented wedge theory. This theory deals with formation of monomolecular layers of emulsifying agents curved around a droplet of the internal phases of the emulsion. See here the droplet surface, here the water, and this is a oil globule. The polar end is the non-polar end. Polar part is hydrophilic, so that is in water, and this is hydrophobic tail or lipophilic tail is in the oil phases. So emulsifier molecules oriented at interface. Dotted lines indicates the large volume. That's the dotted line. Dotted lines indicate the large volume occupied by polar head due to formation of hydrated complex. So that shows that close packing of molecules fits this curvature. So this is water oil interfaces. This is nonpolar end and this is polar end. The area of polar head is associated to molecules. See the dotted lines. Okay. Next is oriented adsorption theory. As per this theory, the added emulsifying agents forms a mechanical film by getting adsorption at the interfaces of the liquid and offers stability to emulsions. However, this theory could not explain the formation of type of emulsion. Next is plastic or interfacial film theory. The plastic or interfacial film theory places the emulsifying agent at the interface between the oil and water, surrounding the droplets of the internal phases as a thin layer of film adsorbed on the surface of drops.